Okay. So when you create an agent, going to be always working with four key elements. And the fourth one, I'm just going to call it the black box. So you have an environment in which you operate.
Could you give me an example? Like what is
Yes. So for example, when you need to create a content, so you want to create a content creation agent,
Mhm.
then everything that's given, the tone of voice, the brand guidelines, the client data or the road,
Yeah, 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 the market
that,
data, whatever, yeah.
that's the environment. But even like the same goes with a thermostat, right?
Mhm,
The environment is where you're actually, the room is the environment.
mhm.
So one, the first thing in how you can interact with the environment is through the sensor. This is a part of every agent. It doesn't matter what kind of agent you build, you will need to have a sensor so you can collect information from the environment. Then, whatever information you got, you're going to put this through a black box. This is this is the intelligence part, right? This is the
Mm.
thinking part. So the black box does something with the data or because of the data it got from the sensor, and then you send it to the actuator. The actuator can be one or multiple things, and the actuator has only one purpose, which is basically to manipulate the environment. So it doesn't matter what kind of agent you build, you will always build this,
Mm.
right?
This is a framework for an agent, right?
This is a classic framework. Like this is not something that I invented,
Yeah,
but
yeah, yeah, I
there is a
understand.
definition of what an agent is. For our case, what we are really interested in are intelligent agents. And when you have an intelligent agent in computer science, it perceives its environment and then takes actions autonomously in order to achieve goals and may improve its performance with learning or acquiring knowledge.
Okay,
This
I
is
understand.
one of the important things. Note that it says it may improve its performance with learning or acquiring knowledge. An agent doesn't have to be able to improve its output in order to be considered intelligent. So
Right.
when you want to build an agent, you always start with this. Look at that. Environment perceives a sensor. Then here's the black box. And then the actuator sends back the action to the environment,
Mhm.
right? Same as here, just with colors.
Right, right.
Okay. So let's take a look at this a bit. Like, how do we zoom into this black box, right? That's gonna be the big question, because how the black box works in most cases will heavily impact what we can or cannot do,
Yeah.
right? Okay. So I'm just gonna mark this with this so we can look at this thing. Okay. So there is a recent study that explains and proved mathematically that you can improve the quality of reasoning with the large language model if you scale the depth of the chain of thought steps.
Okay,
So,
I understand this, I understand that.
right? So, the more steps it is allowed to think through, maybe give a step to reevaluate its position, maybe give another step to gather some, create some mental framework. It doesn't matter. The more steps you give it to, the more complex reasoning it is capable of. And there's virtually, like mathematically, there's no limit to how complex this reasoning can be. The only limit is compute, which that
So this
uh,
is I sorry to interrupt, but this is like this is tr you're training it now, right? This is not just prompting, you're saying, or is it prompting and training?
no. So this is interesting because so far in machine learning, most of the intelligence or the reasoning capabilities were achieved through training. So the marginal cost of increasing the reasoning capabilities of a large language model by 1 unit of
Mhm.
whatever, one
Yeah.
IQ point. That cost mostly lived in training. I give you more parameters to train the model, which is why earlier models were larger and larger and larger, and then GPT-4o was incredibly large. But now what we're talking about, and this is also how O1 works. Instead of training data and training costs, the costs are now living in the inference. Instead of training with give the model more training parameters and running the training for more epochs. Instead of that, they're spending the same compute on inference, which means that I'm going to keep prompting the model. I'm going to
Mhm.
run the model, and instead of prompting it once and getting a response, I'm going to prompt it n number of times. So think about it this way. Um, Prompting means that you have an input. Let's just change the color. Yeah. So you have an input and then you have an output, right? That's
Mhm.
pretty simple and easy to understand.
Yep.
So when I change the input to prompt, I change the output to response,
Right.
right? Now, the inference cost, or how many completions we need to run, can be calculated by the number of arrows in here, which in this specific case, it equals to 1, right? I have done 1 completion.
Yeah, yeah.
But let's see if I do something else. Let's see if I create a prompt and a response, and then all I do is I use that as another prompt to generate another response.
Mhm.
So whatever prompt I got, I send it back to the model, to the same model. And in this case, the number of completions I've done just increased to 2. But here's what happens. In this case, we're still only working with one model, with one instance of the model. So
Yeah.
let's see what happens if I have 2 or 3. So for example, in this case, I can just run the model, and instead of feeding it back to the same agent or to the same LLM, I can have 2 instances. Let's say I have GPT-4o and Claude 3.5, right?
Mhm. Mhm.
So that means I make a prompt for GPT-4o, I get a response, and I feed that response as a prompt, right? As a prompt to Claude. So I'm just going to mark it with a dotted line so it's not confusing, right? And then Claude is going to generate a response for us. In this case, the number of completions is still only 2, right?
You're essentially on the same prompt, right?
Yeah. So this response and this prompt is the same thing, but now this one is OpenAI. So like the yellow one is OpenAI, and say the brown one is Claude. So now I have 2 completions. And this is when things become interesting because where's the cursor? Yeah. So what happens and now we need to change how we visualize this. So what happens if I have multiple agents to talk to? Let's say I have 3. So we tested 1, we tested 2, and we test now 3. So I start with the prompt, right? Which then gives me a response.
Mhm.
And then what I can do is I can send that to the second agent, just like before, and that will elicit some kind of response, just like before. So this is nothing new, right?
Right. Right.
But then what can also happen is that if I want to complete this tree, I will also want to create another prompt and send the same prompt to the third agent as well,
Mm.
and that will also elicit a response.
So you're taking this same prompt response from the first box and shooting it simultaneously to 2 additional agents. Is that right?
Yeah, because here's the reason why I'm doing this. Let me show you a good example of this. So let's say that instead of just mindlessly pushing the prompt forward, let's say that we add a variable which is going to be marked by CI.
Okay.
Okay. I don't know how this one can give me a superscript. So I'm just going to mark it with C1. So for this one, I'm going to add the C1 prompt and I'm going to add the C2 prompt here. This is going to be the custom instruction for the model itself. So
So
let me
they're different. They're different instructions.
they're different instructions, but we already know that the custom instruction plus the prompt is the actual prompt that the model gets, which means that this prompt, the brown prompt and the gray prompt, are actually not identical, right? Because I'm sending it to different personas. So that means that, for example, I get a raw transcript from a meeting, and then I ask a model that's a moderator model. We're going to call it C0. So I'm going to have the C0 model to, hold on, to, its job is only to take the transcript and create a report of everything that has been said, but in a structured format,
Mhm,
right? And
mhm.
summarize this for me. And then I send the summary to C1, whose job is to figure out every single task that needs to be changed. And then there is C2, whose job is to figure out the changes that are mentioned. Don't bother with the task. Just return me a list of actions that need to be done. And this one says, return to me a list of tasks that
Mhm.
are being mentioned or affected.
Okay. So you're separating tasks
Yeah.
and actions out. Okay.
Yes. And then what's happening is I can then send all the responses back to this one, because this, again, don't forget, this the job of this model as defined in C0 is create a summary. So I take this response and I take this response, send it back.
Well, and you concatenate it, basically, you put it together.
Yes, I
Okay.
concatenate it and send it back so I can get a new response. So this is going to be a prompt. So I can just dot this one and dot this one. Let me just way that way. Yeah. And now I get another response. And here's what just happened. This is a pretty simple exercise, but there are a couple of things that we can do here. First of all, I have one, two, three, four prompts here. I'm only
And
using 3 agents through a single exercise, but now I'm having 4 prompts that are being completed throughout the process. So as you can see, the number of prompt completions is going to grow exponentially as you grow the number of agents in this architecture. And the reason why that is important is because this way you can create multiple agents that do single narrow tasks. And instead of
mm,
having a generalized agent that has to take care of everything,
right.
all you have to do is orchestrate an army of narrow agents that do everything separately, but then in a sequential order. So if I add the fourth agent, that's job is to ensure that it adheres to whatever the response adheres to whatever safety guidelines we have, then the fourth agent will infer with all the other three agents at every single time. So we end up doubling the number of completions we have. If I add the fifth agent, that's job is to make sure that it follows a specific tone of voice. It's going to also so we double this again. And again, this is not entirely necessary for every single use case, but this is the baseline on which how you can easily build. And
I understand this. I
right,
understand this. Yeah.
so, so here's the thing. As you build this architecture, this black box, what you're going to need to figure out is how to manage your resources the best way possible, right?
Yeah.
Because O1, the reason why O1 works great is because they just fused a bunch of prompt completions together in a very specific way that they tested. It's an
Mhm.
easy way to do it, but it's expensive, which is why it has very hard limits on how you can use O1. But as a couple of Chinese computer scientists already proven it, I think there were a couple of them were Chinese. As they've proven it, you can increase the number of these steps virtually to unlimited to
Mhm.
infinity,
Mhm.
and you can increase the complexity of the thinking problem that you are giving to them. Now,
In a single usage, is that what you're saying?
but that means that you're scaling the computational costs exponentially, which is a problem.
Yeah, yeah, yeah. Like
So,
servers and, like, chips and stuff like that.
yeah. So obviously, if you kind of let everything go in your mind and you go completely unhinged, that means that, quantum computing can easily solve that in the future.
Mhm.
This is one of the key components that we will need for AGI, that you need to be able to scale compute. And
Mhm.
when Sam Altman wrote the article about the intelligence age, and he says deep learning works, this is what he meant, because deep learning as a field of study says that, hey, our hypothesis for deep learning is that if we scale compute, with more compute, more thinking or better thinking we can get to. We can teach the computer to think better if we give the computer more resources,
Yeah.
right? And now with this proof and the working prototype, working example of O1, we now have proven that the core hypothesis of deep learning is true. That doesn't mean that we don't have a lot of other stuff that need to be done, because formal logic is still non-existent in neural networks, right?
Yeah.
So that's why code artifacts are important, because code is formal logic. So if an LLM has the capability of writing working executable code and is capable of executing it, then it can complement its neural net with a symbolic system. Basically, I need to figure this one out, but this requires formal logic. So I'm gonna write the code, run it, and whatever the output is, I can use it. Because here's what it looks like. So let's see, the response we have here is a piece of code, right?
Yeah.
So we get an execution here, and then from the execution we get the result. And then I take the result and just send it to another agent, and then I can keep going for as long as I want.
Yeah, yeah.
So, and now we are having an agent that not only runs through LLMs but also manipulates data through code. And this is why Make is incredible, because you can take this and instead of running a custom code, you can just use a no code application. I'm gonna mark that with a circle because that's how Make shows them, right? So you can just use any make module, or you can use any Zapier module
Mhm.
and virtually achieve the exact same output. I got an LLM response, and now I'm sending it to this no code module to manipulate it somehow for that use case. And then whatever the output of that is, I'm going to send it back to an LLM, or I'm just going to show it to the user.
Yeah, yeah, yeah.
And that's how you build an agent.
Can you go back to the left side, back to the very left side, the basics? So we just talked about the black box,
Yeah.
right? And that's could be a series of modules in Make, like a big branch that are connected to various services like LLMs and spreadsheets or whatever.
Yeah.
Can you talk a bit about the actuator?
Yeah. So if you build it in Make, then your actuators are also going to be Make modules. But I want you to think about it different. Think about it in a modularized way, because that will allow for a lot better management. So let's say we have this actuator here, and there you go. So with an actuator, you basically end up, so this was the final response, right? And here, I just send the final response to a army of actuators. So what I would start here as an actuator is, so I would have a moderator, or let's say orchestrator,
Mhm.
an orchestrator agent. And the orchestrator agent's only job is to decide where to send this response. Okay. So I had this response, and then I add this to the orchestrator agent and say, tell me which actuator do I need to send this data to? And then it gives me a response. And based on the response, then I end up having a bunch of different modules here. And then basically, this is where a decision is being made.
Right.
And
This is like the data processing or the task
yes,
completions or whatever.
correct. Now, the important thing is this: the way I would run this in Make is that the brain is one make scenario,
Yeah, yeah.
or you can run multiple scenarios. It's not needed, but the black box is one make scenario. And then what I would do is, depending on the actions you want to define, you can define each action as a make module or a make scenario. But what I would do,
Yeah. Okay.
right? So what I would do is that, let's say the brain came up with a final response, and then after the final response, I run a make module that triggers this actuator orchestrator. And then the actuator orchestrator runs, it inherits this response, it gives me another response, and then just basically through a filter, I create a router, a filter for 4 different routes. And then if the end result was 1, then run this scenario. If the end
Yeah.
result was 2, run this scenario, this scenario.
Yeah.
And then you can just virtually create any scenario. The moment you know what the input is that this make module needs, you just need to create a brain that is capable of thinking that input out based on the raw
Mhm.
material and the raw
Mhm.
data. And
Mhm.
then you just build an automation.
And that's, like, where your knowledge of which tools to use, prompting, obviously,
Yeah.
I guess data handling and all that kind of stuff.
Yeah. Sensor are also the same thing. You just need to understand the information architecture of the environment, which is the client's text. If you
Right.
understand the information architecture, then you can set up triggers in Make, saying when this happens, when that happens, that's going to be your sensor.
Could you go through, like, a real life example of what this would look like? Like, just so that You can something maybe you've done or, like, something that you can just
Okay.
make up?
So the one example I gave you was the transcript thing. So this is actually a live project that I'm working on for a client.
Okay.
Construction project. So construction projects get delayed because there's a lot of moving parts, a lot of
Mhm.
contractors to manage, and they're usually not very digitized. So most of the construction companies do have status meetings, but they are done offline on site, right?
Mhm. Mhm.
So in this project, our job is to make sure that whatever is said on that meeting is not only recorded, but also translated into their own project management system and QuickBooks, because they create an estimations and they create the project
Work
plan.
orders, stuff like that, yeah.
So they need to change the schedule. They need to change the estimate as they learn new information, and that usually never happens, which means that the project estimation in QuickBooks is outdated the minute it's done. So how do we solve that problem? They already have the meetings, so we just need to record it. And again, this is, I think, is an incredible example of using cutting edge technology to solve problems without having to change customer behavior or
Right.
user
Or
behavior.
or technology, right?
Yeah.
Yeah.
So, and this is important because before you would need to use some kind of software.
Yeah.
Now, all I need to do is ask someone to launch an app on their phone, and that's it. And then the recording is done. And when the recording is done, it just passes it through the whole thing. It can even be a shortcut on your iPhone.
Yeah.
Um,
Right.
so what happens here is that, again, as I said, you get the transcript. And this is actually a live example. One agent's job is to get the tasks, and another agent's job is to find what needs to be changed. And
Mhm.
there then a matching happens. So this task needs to be changed to this. This
Mhm.
task needs to be
Mhm.
changed to this. Then what happens here is a search is being made in the SQL database to find the tasks that are being mentioned here. So now I'm sending back the task that is verified. It's not just verified from the transcript, but I actually took the transcript, went into the SQL database and said, "Hey, somebody said bathroom tiles. Can
Mhm.
you find me the relevant task item for this project in the database that is hosting every single
It's already there. They already have
already
these.
there. Find
Yeah.
me what it is." And then it says bathroom tilings or something.
Mhm.
So that means, oh, that's the task. And the current estimate for that is 2 weeks and $5,000. But Susan just said that the contractor is being late. So the new estimate is $7,000 in 4 weeks.
Mhm.
So now I'm sending that information back to this one. And now this is verified. And this is the change. And this is what needs to be changed. So then, okay, now this one summarizes and says, the contractor is late, so we need to change the deadline from 2 weeks to 4 weeks, and we need to change the cost from five to $7,000. And then what happens is it sends this information to an orchestrator module that does multiple things. One, it it triggers the actual database change as long as a
Con
criteria is met, and that
conditions are met,
criteria
yeah.
is user approval. So first I need to send this back to the user and say, "Hey, from this meeting, we had this change suggested by Susan. Should we do this? Is this accurate?" And if the user says yes, then this just runs and the estimate and everything else is updated. This is not an intelligent thing. This is pretty much hard coded logic, right? This does not necessarily have to have AI in it at all.
Mhm. Yeah, right, right. It's like a Boolean thing. It's just
Yes. So I think this is a prime example of how you do a verified search in a live database. And as you can see, you don't need RAG in a lot of cases because you don't need to learn everything about everything. If you can
Yeah, yeah,
generate a prompt that will generate a search query, then
yeah.
you're golden. So this was a live example for that.
Wow, that's incredible. So when you let's say you're approaching a client and they give you their scenario or their problem, I'm assuming you're gonna go through this problem and map out every single point of, like, you know, every point of what needs to happen, right? Or what it looks like.
Yeah, yeah. So usually what I like to write up is not just a schematic like this, but I actually have to figure out what are the different modules and how do they connect to each other. So I show them connected, unconnected sequence of make modules saying,
Mhm.
now we do a SQL search. Then we do, I don't know, Airtable, something, something. Then we have a router here. Then we have the filter set up here. In this case, we call Gemini. In this case, we call OpenAI. In this case, we do an iterator in Make and whatnot. So I map out the entire architecture because by that time I'm able to do that, I've already spent about 4 hours on the project.
Mhm.
So I have a pretty good understanding of the problems and the objectives of this project,
Yeah.
right? But then once I have done that, I'm able to actually pretty clearly articulate what needs to be built. And that creates a very detailed scope of work with an impact, understanding, understanding the impact of it,
Yeah.
right? And basically the offer I give to the client is, hey, here is how this would look like. But they do see all those red little dots, you know, how make looks like when you create a. Okay, so do you see those red little dots? That means that they're not working. So if you pay me, I'm going to make them work.
You're saying, "I'll turn it on for you." I'll
And that's literally it. And
That's
I'm
funny.
going to configure it for you because you make it real. It's
Yeah,
not,
yeah. They're
you know,
seeing something tangible, and you're also telling them by showing them, I guess, the schematic and also saying, "This is what it's gonna do for you," right?
yeah. And then if the last bit of this conversation is always about user experience, because in this example that I showed you, all the user needs to do is start the voice recording every time they have a meeting.
That's
But
it.
I stress that it's very important that you need to start it, but also in here, you need to approve
Mhm,
changes.
mhm.
So I end up creating some kind of an SOP saying every week, every Tuesday, you have the meetings on Monday. Every Tuesday, you sit down and you do a power hour when you just go through every single change request and approve, edit, or deny. If you
Yeah.
don't do that, then you're just going to create digital trash.
Yeah,
Not
right,
going to
you're
do
wasting your
anything.
time and money,
You're
yeah.
going to be wasting resources and compute and your time. Same thing for the content generation machine project that I'm working on for the other client. They the machine generates a lot of ideas and generates a lot of raw content, but it needs to be approved. And this is the interesting part that needs to be coming with a mindset shift, which is for content creation, the marginal cost of creating a new piece of content is incredibly high. So that means that you do the quality control first and you do the creation second. But with AI and these kinds of agents, it's the other way around because now the marginal cost of
It's
creating
low.
content
It's low,
is
yeah.
incredibly low. But
Right.
then quality control has a lot more emphasis because now instead of me thinking about what I want to do, I can just look at 100 different options and choose.
That's my argument actually, or my thesis is that editors are actually now the new, like, boss of the content world, you know?
Yeah.
Like,
I mean,
it's
editing is now more important than just raw content creation.
correct, that's correct, yeah. Wow, man, that was a master class, thank you. That was incredible. What I do from here, like, I guess that I just need to start mapping out like this, like the goal, right? And sort of the points of what needs to happen during this pathway from point A to point B. And then knowing knowing make enough and the module is enough to know what goes into each of these the mechanics of each point, right?
Yeah. And always go back to the logic of, just creating an agent is always like, what are the sensors and what are the actuators and how does the environment look like? And then you can start thinking of the black box. But I always leave the black box to the very end
Mm.
because the
That's
client knows what the end result is, and the client what's the desired outcome is, and the client also knows what the starting conditions are. What the client doesn't know is how to get there. So
yeah.
one thing that I constantly battle with is the client comes to me asking for help in figuring out the how, but they're not qualified to find out the how. If they were, they wouldn't be having a conversation with,
Mhm. Mhm.
which means that I need to divert their focus from the how to the what.
Yeah.
Instead of telling me how to do my job, tell me what can I work with and when do you consider this job to be done?
Mhm.
And
Mhm.
if I have both, I'm going to be able to figure out the how myself.
Exactly. Wow, man. Thank you. That was that like
I'm just going to upload this to YouTube.
please do actually, because I want to review it.
I'm just going to take this raw thing and record it to
Cool.
I'll
Yeah, do
upload
that.
it to
And
YouTube.
hey, let's stay in touch. That was really cool. Like really good talking to you and kind of just getting to know you a little bit more. Man, I got to figure out how where to step into this because it's quite vast. Like, but it
Yes.
seems like once you get like the I don't know, like
It just needs
the
to
way of
click.
yeah, the way of thinking. Like once you get the way of thinking, it doesn't seem that difficult, right?
Yeah, it just needs to click. It just is. If you ever played with Lego,
Yeah.
it's the same thing.
Yeah.
And
Yeah.
here's the thing that there are a couple of stuff that I don't like to do when I'm building these kinds of things. So first of all, I don't like to build products like production ready products with this
Mm.
approach
Mm.
because there's a lot of challenges, scalability, security that might require just coding, right?
Mhm.
So if a client comes to me and says, "Hey, I want to build a product so I can commercialize it and monetize it," then I'm happy to prototype. But then the moment it's done, I say, "Look, make some money with it, and then hire a team to build this for you because that's going to be like you're creating a tech company. You
Yeah,
cannot
you're
outsource your
creating exactly, and you're gonna need a team to maintain it and all
yeah."
this kind of stuff, and yeah. Yeah.
But when it comes to process automation for businesses, and this is kind of my sweet spot, that there are like 2/3 of the small business world do not have a full-time developer, not a single one,
Yeah.
right?
Yeah.
Which means that most of the high knowledge professional businesses, the people businesses that require a lot of professional expertise, and this ranges from
Like lawyers, like law firms
lawyers,
or
bookkeepers, but
yeah.
even HVAC experts, right? Or
Yeah. Yeah.
carpenter, or
Yeah. Home
there's
inspectors, like
home
developers, yeah.
inspectors, real estate agents. So these are the kinds of businesses that do not require a full-time developer, but they do require handling information and data, which means that their tech stack is usually a patchwork. It's a
Mhm.
bunch of different unconnected pieces of software.
Yeah.
And without knowing, they do have a tech debt. So until now, their main go-to solution was to just hire somebody to make sense of it and then build a custom software product.
Mhm.
And here's what happens. if I'm a small business owner, I hire a developer, a freelance developer to build some custom solution for me. I pay
Oh,
30, 40, $50,000 for it.
sound
They
good.
leave. And then I just created a problem for myself
Yeah.
because now I have to maintain it. Now
Mhm.
I need someone who can manage that tech stack and that product. And now all of a sudden I have an IT department.
Yeah.
And so for those companies, no code solutions are a lot more preferable than just building something with code, because building something with code means qualified maintenance, and the bar is here for code and it's here for no code. Like, you can teach an intern how to manage a make automation because there is a training on it. It's good and it's free.
Yeah. Right. Right. Okay. All right. Now I need to like contemplate this for a while. I'm gonna start building some stuff